Hi everyone, here I continue on topic number 5. So this is video number 2. Okay, so I can see this question. It says as long as a plant or animal is alive, the amount of C14 is constant in tissue. Once dead, so the amount of C14 is decreasing. Okay, so the equation is like this. So if you compare the equation that you see here with what we already learned, okay, so you can say we have half-life in the equation, okay, so that's the blue type that we see. So see here when we just showed this part, that was the blue formula. So when we compare, it's that, okay, and the half-life is 5590 if you can just check the formula. Okay, so it says what is the half-life. So let's say we don't know. Okay, so here we can find it. Okay, what does half-life mean? Means the time that it takes AT would be A0 divided by 2, half-life. Okay, so how long does it take that we go from A0 to half of that? Okay, so A0 is A0 2 power minus T this, divided by 2, this and this cancel, so I have so I have 2 power minus 1 equal 2 power minus T over 5590. So I have minus 1 equal minus T over 5590. So I have T equal 5590 years. And how do I know? Because it says T is in years. Okay, so what I said was correct. So I said this is half-life. Okay, so T 1 over 2, which is that G that we used to just use it in the formula, is 559 years. Okay, so now it says calculate the rate of C14 decay. So remember, half-life is ln 2 divided by K, right? Ln 2 divided by K. So now you can find K here. Okay, so K is ln 2 divided by T of that. Okay, so ln 2 divided by 5590. Okay, so which is, if you use your calculator, ln 2 divided by 5590 is 1.239. 1.239 times 10 power minus 4, okay, which is, I can underline that, check that, to 3 significant digits, 1.24 multiple 10 power minus 4. Okay, so this is per year. Okay, yes. Why? Because the unit of time is year here. Oh, okay, so now it says find the age using a base of E of a fossil if 10% of the original amount of this is still present. Okay, so here it says using a base of E, means I want you to use this formula. So AT is A0 E power minus Y minus, because it's decay, so Y A0, because we start with A0. Okay, so we have it. So what is K here? K is here. Okay, so K is here, 0.000124. okay, and again, if I want to use 124 here, it will be wrong, because then it will be, so just 1 second, I close this window. Yes, then I don't receive email. Okay, so then it will be just rounded and rounded, so I don't want to do that. So I want to use more digits for K. Okay, yes, here I stop here because I'm finishing part A. But right now when I want to use here, so I do 0.0000123 123,997. Okay, so when I want to use for the next part, I need to use more digits, because otherwise I am rounding and rounding and rounding. So I don't use rounded answer for the next part, because then my answer is not accurate. Okay, so I have this and multiple t. Okay, it says using this formula, it's asking me. Okay, so find the age means how many years of a fossil if 10% is still present. What does that mean when I say 10% is still present? Means AT is 10% of A0, which means A0 10 divided by 100, which means A0 divided by 10, which means 0.1 multiple A0. Yes, that's 10%. And it says it's still present. It doesn't say 10% is gone. No, 10% is present. Oh, okay. So 0.1 A0 equal A0 e power minus this. Okay, so now I cancel this and that, and then I can find the answer. So ln this is t ln e is 1. Okay, so then t is ln 0 1 divided by, and don't worry, ln 0 1 is negative, so the negative and negative, they cancel each other. Okay, so ln 0 1, okay, divided by this number. Okay, which is 18569. Okay, so it says how many years. Okay, just 3 significant digits. Okay, so I just don't show after decimal. Okay, this many years, and I underline that, I check that it is almost 18600 years. Okay, 18,600 years passed when I just have, when 90% is gone and I just have 10% left. Okay, so try to understand the question, try to just, and make sure show me the units, for example years or hours or minutes or what. Make sure to show me the conclusion sentence. Okay, here I didn't include it because I don't want to just you use your time in the video, but make sure you have conclusion sentence. Conclusion sentence important when you have word problem, otherwise I reduce mark. Okay, so now I just want to show you something. I just want to show you why I have that formula when I can have other type of formulas. For example, if you check the book, you can see other type of formulas. Okay, I do not want you to know this. I do not want you to prove it for me. No, you don't need to prove it for me. No, I just want you to know. Okay, see, if I have $1,000 and it's invested, it is invested for 12% per year, and I just calculate what I have as interest, for example, once a year. Okay, this is the formula. If it is twice a year, yes, I use 2 here. If it is every 3 months, I use 4 here, because it's every 3 months means 4 times a year. If I have every month, it's 12 times a year. If I have every day, it's 365 times a year. Okay, then I want to show you when I say continuous means all the time, what happened. Okay, so I show you this formula here. This is the formula. Okay, see, I multiple with look at this, I multiple with n and then divide by that, and this is k, and see, you can see the formula. Then I multiple the power with k. Okay, and I divide by k as well. See here, Instead of nt, I am using kt multiple n over k. Okay, then I can say n over k is m, for example, and I can say, okay, instead of this, I have this formula. Do you remember this formula? It was 1 plus 1 over n power n. Do you remember that from topic 3? No, sorry, from topic 2. From topic 2, exponential. Do you remember this? I said this function, or maybe topic 1. I forgot. Okay, so I have to check. So I told you when m approaches to infinity, this is e, if you remember. Oh, that's why I have e. That's why I have n0. That's why I have n0 e power kt. That's why. So what do I mean by m approaches to infinity? M approaches to large number. It means when it happens all the time. When it happens continuously. So it's not once a year. It's not 365 times a year. No, it's all the time. So when it is continuously and all the time, I use this formula. This is just a reason I want you to know. That's it. So just use the formula. When you know the reason, based on my experience, you don't forget if you know the reason. But I'm not going to ask you what is the reason for the formula. Okay? So when it is continuous and when it is all the time, this is the formula. Okay, so now I want to practice. I want to do practice here. Okay, so let's do practice. A population is decaying exponentially at a at a continuous rate. See, it says continuous, of 2% per year. Per hour. This is decay because it says decaying. Okay, so how long will it take the population to decrease to a value equal to 1 over 3 of the original value? Okay, means a0 divided by 3 equal a0. Okay, e power. Do I use 2 power or e power? E power, because it says this is the rate. I have the rate. E power minus y minus, because it's decaying. Okay, so minus 0.02 because it said 2%. I use 2% like 2 over 100. Okay, t. Oh, perfect. So I can cancel this and this, and then I have 1 over 3 equal e power that, and then I do ln of both sides. Okay, then I have ln of 1 over 3 equal this. Okay, ln e, which is 1. Okay, and t is ln 3 power minus 1 divided by this. Okay, and the answer is, okay, ln 1 over 3, or just ln inverse of 3. So ln 1 over 3 divided by, yes, it's minus 54.93. So I underline that, check that, it is almost minus 54.9 hour. Okay, so it says 2 significance, sorry, so 2 significance. So I just do this underline and check that it is oh, sorry, not minus. So just minus and minus cancel each other because ln 1 over 3 is negative. So yes, it is 55 hours. Okay, after 55 hours, a0 reaches to a0 divided by 3, means 2 over 3 of that is gone. Okay, how long is required for the population to decrease from 10,000 to 2,000? Okay, means 10,000 is a start. Oh, okay, so 2,000 equal 10,000 e power minus that. Okay, so it is 1 over 5 equal e power this, which is ln 1 over 5 equal this, and t is ln 5 this over, I don't need to make it harder for you because you can just use a calculator. Okay, so this one. Okay, so it is ln, okay, so yes, okay, so this, yeah, okay, so it's 80.47, right? and then it says three significant digit. Okay, so I underline that, check that it is almost 80.5 hours. 80.5 hours. It takes that we go from 10,000 to 2,000. Okay, so make sure to write sentence, make sure to include the unit, make sure to do that. Okay, so how about here, how about this question? Oh yeah, okay, so how about this? Strontium 90 has a half-life of 25 years. Half-life. Okay, I have half-life. How long would it take 4 milligram of it decay to this? Okay, so this is N0. This is N. I am looking for T because it says how long. What is this? This is G. Okay? In this case, you don't use formula K. You don't use it. You use the one that has G. Okay? Decay. So 2 power minus T over G. Okay, so it is 2 over 4. Sorry, 2 equal 4. 2 power minus T over 25. So it is 1 over 2, which, okay. So it is, yeah, I do step by step. 1 over 2, 2 power this. And this is 2 power, oops. This is 2 power minus 1, that's 2 power minus T over 25. And minus 1 equal minus T over 25. And T is 25 years. Is it 25 years or, let me see, or hours? Okay. Years, yes. Years. Does it make sense? Yes, of course, because I want to go from 2 milligram to 4 milligram. Sorry, from 4 milligram to 2 milligram. So exactly is half. So that's half-life. Makes sense. Okay. How about that side? How about here? Okay. How about this? Oh, okay. So 0.25. Okay, and remember, see, here is 4 milligram and the other one 0.25 milligram. Make sure that you are paying attention to all of these units. If units are not the same, you have to change. Okay, so it is 4 2 power 2 power minus T over 25. Oh, okay, so then I have 0.25 over 4 equal 2 power minus T over 25. Okay, so it is ln this equal minus T over 25 ln 2. T is 25 ln. Okay, 25 multiple that, and I want to find T. So 25 multiple this, and then divided by minus ln 2. Okay, from here to here is just solving equation. It's just math 171. Okay, you are just solving equation. Okay, so, and the answer is T equal, okay, T equal, let me see. Okay, so 25 times ln, just want to make sure. Oops, I need bracket when I want to use ln 0.25 divided by 4 because it's ln all together. Okay, so yeah. Okay, so yes, it is 100. Okay, so just 100 years. T is 100 years. Okay, and makes sense because from 4 goes to 2, 25. From 2 goes to 1, 25. 1 goes to half, 25, and half goes to 0.25. Okay, so 25 years, 25 years, 25 years, and 25 years, and when you add them all, it's 100. Okay, makes sense. Okay, so then okay, then I go to here. Okay, I go to the next question. Okay, so the next question, I'm not going to do it. I'm just going to explain, and so because it's very similar. The doubling period of a bacteria is 15 minutes. Remember, it is doubling period, and so I use, and it says doubling. Okay, so we use the one with 2 power. We use the blue one. Okay, so how many bacteria will there be after 45 minutes? Okay, what is the formula? The formula is okay, it starts with this. That's n0. The formula is 5000. Okay, that's 15 minutes. So 2 power t divided by 15. This is the formula, and that's nt. Okay, that's a formula. Do I have n0? Yes, this is n0. Do I have doubling? Yes, this is here. So when it says doubling, I use positive here. When it says doubling, I don't go for k. I don't go with e. I go with 2 power. I don't bother with k. It's not talking about k at all. Okay, so here I find n of 45. So you can continue as homework. Here I use n of 1.5 hours, which must be equal n of 90 minutes, because I have to convert with each other. One of them is hour, one of them is minute. No, I have to change it to minute. So homework from here. Okay, so how about this? This question is also homework. So 5 million bacteria live in an organisms. Okay, so the doubling period is this, 1.5 hours. How many will be there after this? So 5 million is n0. N0 is 5 million. Okay, so doubling period G is 1.5 hours. Okay, so I just use the formula. So here the formula is 5 times 10 power 6 times 2 power and 9, which is okay. So 9 I use red, divided by 1.5 hours. Okay, this is the answer. Okay, just find the answer. Okay, how about 2 days? Oh, this is hour, this is 2 days. So 2 days is 48 hours. So make sure you change it. So it's 48 divided by 1.5. Make sure that you you convert, and at the end, what is the unit, how many? Okay, so for example, and is it bacteria, is it how many hours, is it how many minutes? And make sure to add the conclusion sentence units, don't forget. Okay, so yeah. Okay, so now I'm going to do this one, and let me see, 1 2. So how many questions are left? Okay, yeah, so just 1 second. Oh yes, yeah, okay. So a bacterial culture starts with 300 bacteria. After 3 hours, this is the estimation. What is the doubling period in minutes? Okay, okay. So just be careful. See, this is a start. Okay, so n0 is 300. Make sure to write what you have. Okay, after 3 hours. So after 3 hours, so it's n 3 hours is 48,000. Oh, okay, so n 3 hours. What is the doubling period in minutes? Means you find the doubling period in hour, and then you go to minute. Okay, so doubling period. See, I don't hear anything about k, so I go by 2 power. Doubling means 2 power positive. Okay, so 300 equal 48,000. Okay, 2 power 3 over g, right? Yes, I am looking for G. I have 3. Yes. Okay, so 3 is T. Okay, so then you find the answer. Then you find the answer G. Okay, make sure you find the answer G as homework. Okay, you find G. And then from G, which is hour, make sure that you go to, so G is, so find G as homework, and then G is in hour. Let me see, is it in hours? Yes, in hours, because it's a 3 hours. So then change it to minutes. Okay, and see how many minutes. How do you change it to minutes? You multiply by 60, because 1 hour is 60 minutes. Okay, so make sure that you do the question here. I am going to post all the solution, okay, here, so you are going to have access to the answer. Okay, so how about this question? So here, yeah, so the half-life of this is 4 days. Okay, so G is 4 days, and that's half-life, so I have to go with negative one. 4 days. After 16 days of a sample, reduced to this many gram. Okay. Oh, so T is 16 days, and the sample NT is 0.75 gram. Okay. So what was the initial value? I'm just looking for N0. Okay. So it is 0.75 gram equal. Do I go with 2 power? Yes. 2 power negative? Yes. Why negative? Because it says half-life. Why 2 power? Because it's talking about half-life. Okay, so I don't have anything about K, so I don't bother. I don't go to E. Okay, so I have to make sure which formula is useful for me. Okay, so that's that. And okay, N0, 2 power minus 16 divided by 4. Okay, which is N0 2 power minus 4, and N0 is 0.75, yeah, multiple 2 power 4, which is 12 gram. Okay, so make sure to have the unit. Is it gram? Is it kilogram? Is it what? Have the unit. Make sure to have the conclusion sentence. The next part, just homework, because it says what is the mass after 2 days. You just have to substitute T equal 2 days. But remember, days, 2 day is okay, day is fine because all of them are day. Okay, you don't need to do any conversion. Day is the same as day that I see from the beginning of the question. So half-life is days, so this is days as well. Okay, what is the mass after 2 weeks? Remember, 2 weeks is how many days? 14 days. So 2 weeks is 14 days. Make sure you do the conversion. Okay, make sure that you are careful about units. If you have to do changes in unit, do it. You have to state the unit. Okay, so here, yeah, I'm going to stop here and then I continue in the next video. So this is video number 2. Okay, yeah, thank you so much. Thank you for your time. Bye.